Have you heard about Spring Integration 6.4? Of course, you haven't. And that is the problem. This update, it's game-changing, but they don't want you to know what's really in it. Sure, they will tell you about dependency updates. They will distract you with fancy terms like base message builder and control bus factory bean. But what's really happening here? Oh, it's bigger than you think. Let's talk about the hidden gems. The ones buried so deep, you'd never find them on your own. Like the control bus interaction model. Sounds boring, right? Wrong. This tool is quietly rewriting the way developers manage commands. And let's not forget the SPL evaluation upgrade, a JSON index accessor. Why would they even need that unless there was something much bigger at play? But here's the kicker. While everyone else is focused on the flashy features, there's a deeper story, a darker story, hidden in the issue tracker tickets. If you're not paying attention, you will miss it. And trust me, you don't want to miss this. So buckle up. Let's dive in. Together, we will uncover what they're not telling us. Because in the world of Spring integration, the truth is never what it seems. They added a configuration option for the Java DSL SourcePollingChannelAdapterSpec. Sounds fancy, right? All it really means is that you can now use a custom task scheduler. Big deal, huh? Wrong again. This change is sneaky. They don't just add features like this for fun. It's a subtle nudge towards giving you more control, but it also comes with strings attached. And then we have the remote file adapters changes. They've added a clearFetchedCache API to the abstract remote file streaming message source. Oh, how nice of them. A tool to clean up the cache. But don't be fooled. The real story, this is for when polling configurations can't process everything in one go. Why? Because server rotations between cycles can cause chaos. If you're not careful, you'll be juggling unfinished files, server switches, and unexpected behavior. It's like they're handing you a loaded tool and saying, good luck. Now, let's dive into the JDBC changes. Here's the big one. The LobHandler API is being deprecated. Sounds innocent, right? No, this is a clear signal. Spring is done holding your hand with blob and clog data. From now on, you're at the mercy of your JDBC driver. And did you catch the twist? The JDBC LockRegistry.JDBCLock.Unlock method now throws a concurrent modification exception if the lock's ownership expires. Think about that for a second. You don't release the lock in time. Boom. Exception. Why? Because Spring wants you to pay attention. No shortcuts. No slacking. If your distributed lock fails, it's on you. This is Spring's way of saying, step up your game, or don't bother showing up. Now we're getting into the real tech secrets, the ones they barely whisper about. Let's break these down, one by one. 0MQ changes. Did you notice? The 0MQ message handler now allows binding to a TCP port instead of just connecting to a URL. Sounds like freedom, right? Wrong. This is about control. By giving you more options, they're also expecting you to manage more complexity. Miss a port configuration, your app becomes a ticking time bomb. Redis changes. Oh, this one's a classic Spring gotcha. The RedisLockRegistry.RedisLock.Unlock method used to throw a legal state exception. Annoying, but manageable. Now, it throws a concurrent modification exception if the lock expires. Let that sink in. This isn't just a minor tweak, it's a warning. If you're not renewing your locks properly, things will break. And guess what? They even added a set renewal task scheduler for periodic lock renewal. Sounds helpful, right? But here's the catch. If you don't configure it correctly, your locks might expire silently, and when they do, it's on you. Groovy changes. The control bus factory bean is deprecated. Why? Because they've replaced it with a shiny new version based on the control bus command registry. This is Spring telling you, we're moving on. Keep up or get left behind. If you're still using Gint Groovy control bus, you're practically living in the past. SFTP support changes. Now, the default SFTP session factory exposes the consumer SSH client configurer. Translation: you can customize the internal SSH client however you want. But remember, with great power comes great responsibility. Misconfigure this, and your secure file transfers are toast. MQTT support changes. Spring just upped the ante here. Now, you can dynamically add multiple instances of MQTT payload message-driven channel adapter at runtime. Cool, right? But don't miss the fine print. If your client manager isn't properly set up, you're looking at a world of headaches. And then there's the new MQTT message not delivered event. Why is this important? Because they know delivery failures are going to happen more often. This is their subtle way of saying, you better handle this or suffer the consequences. Zip support changes. The ZipTransformer now exposes a fileNameGenerator property. Sounds harmless, but think about this. What happens when your zip file file names collide or your custom generator fails. Exactly. This is a silent disaster waiting to happen. Scripting changes. Python scripts. They're now evaluated using GraalVM Polyglot. This is a huge shift. GraalVM is powerful, sure, but it's also complex. If you're not familiar with it, good luck debugging your scripts. This is Spring's way of saying, adapt or get out of the way. Mail changes. Finally, the abstract mail receiver now lets you disable the fallback flags. Flag.flag. Sounds minor. Think again. This could mean the difference between catching a critical email or letting it slip through the cracks. So, what's the takeaway here? These changes are not just updates. They're challenges. Spring is raising the stakes, expecting you to rise to the occasion. Alright, let's dive into this step by step, breaking down what's really happening here. I'm going to explain everything as if I'm walking you through the inner workings of this test class. Pay attention because this isn't just about code, it's about understanding the intent behind it. Let's start at the top. The Control Bus Controller Tests class is your battlefield. The annotations at the top, they're not just decoration. They're telling the Spring framework, set everything up, load all the components, and be ready for anything. First, there's spring.JUnitWebConfig. This annotation is critical. It ties everything together, the configuration, the web context, the beans, everything. Without this, you're flying blind. Then, there's dirty's context. Why? Because once the test runs, Spring resets the context. Clean slate. No leftover side effects. Without it, chaos. Now, look at the fields. We have the web application context. This is the heart of your Spring application in a web environment. It holds everything, controllers, beans, configurations. And we're injecting it right here to hook it up to the mock MVC. What is mock MVC? It's your pretend client. It acts like a browser but doesn't actually run a server. You can fire HTTP requests at it and check the responses. And the star of the show, the test management component. This isn't just another bean. Oh no, this is the component whose operations we're exposing to the world through Spring's control bus. The setup method. Every test starts here. The setup method is simple but essential. It initializes mock MVC with the web application context. Without this, the tests won't know where to send their HTTP requests. Think of it as plugging the system into the wall before flipping the switch. The first test, all commands are registered. This test is all about visibility. It asks one big question: does the control bus see all the commands it's supposed to see? Here's what happens. A GET request is sent to the control bus endpoint. No tricks, no parameters, just, hey, show me what you've got. The response: it's JSON, a list of every command Spring knows about. But this test doesn't stop there. It starts digging. First, it checks that the status is 200 OK. No errors. The server is alive and well. Then, it looks at the content type. Is it JSON? It better be. Next, it dives into the response body. Every command is listed here. Commands like testManagementComponent.operation, that's a method from our custom bean. TaskScheduler.setPoolSize, a system-level command, adjusts the thread pool size. IntegrationHeaderChannelRegistry.runReaper, a cleanup operation. _or.springframework.integration.errorlogger.isRunning, a diagnostic tool. Even the overloaded methods are accounted for. You've got one that takes an int, and another that takes 2 parameters. Spring doesn't care, it registers them all. This test makes sure nothing slips through the cracks. The second test, commands for bean. This one zooms in. It's not about every command anymore. It's focused, targeted. The question here is, if I ask for commands from a specific bean, do I only get what I'm supposed to? The bean in question is test management component. The endpoint, control bus test management component. The response, a filtered list. Only the commands from this bean. Again, the test checks the basics: status, content type. Then, it dives into the body. Does it list operation? Yes. What about operation 2? Also yes. Anything else? Nope. This is modularity in action. You can scope commands to specific components. No noise, no clutter, just what you need. The third test, control bus command is performed of a REST call. This is where it gets real. The first 2 tests were about registration and visibility. This one, it's about execution. Can the control bus actually do what it promises? Here's how it works. The test sends 2 post requests. First post, it targets control bus test management component .operation. It passes a JSON body, inside, a value 1 and its type int. Spring takes this input, finds the matching method operation int, and calls it. The test doesn't just assume this happens. It verifies. It checks that the invoke command method in control bus controller was used. Then, it checks the actual bean. Did the operation int method get called with the value 1? If yes, success. Second post. This one targets control bus test management component .operation 2. No parameters this time. It's a no-arg method. Spring calls the method. The response. It returns 123. The test checks the status, the handler, and the content. Everything lines up. This test proves that the control bus isn't just a passive registry. It's active. It takes commands, interprets them, and executes them. The configuration. The context configuration class ties it all together. Enable web MVC. This activates Spring MVC. Without it, the controller doesn't work. Enable integration. This brings Spring integration into play. It's the backbone of the control bus. Enable control bus controller. This one is special. It automatically sets up the control bus controller. That's the piece that listens for HTTP requests and maps them to commands. Then, there's the test management component. This bean isn't just a plain Java object. It's wrapped in a spy. That's a Mockito feature. It lets the test peek inside. Every method called is tracked. The test can verify exactly what was called and with what arguments. The test management component. This is the beating heart of the tests. It's marked as managed resource. That's a JMX thing. It means this bean is manageable. Its methods can be invoked remotely. The methods themselves, they're simple. Operation, no arguments, no return value. Operation int takes an integer. Operation int string takes 2 parameters. Operation 2 returns 123. The annotations managed operation expose these methods as commands. Spring picks them up automatically. What does this all mean? This test suite isn't just about functionality. It's about trust. Spring Integration's control bus is powerful. It lets you dynamically invoke commands via REST. But with power comes risk. Every command is an entry point. Every exposed method is an opportunity, for good or for harm. These tests ensure that commands are properly registered. Commands can be scoped to specific beans. Commands execute as expected. Without these safeguards, the control bus could easily spiral out of control. Misconfigurations, missed commands, security holes, it could all go wrong. This class is the gatekeeper. It ensures that the system behaves exactly as it should. No surprises, no mistakes, just pure, controlled functionality.